Not every single module is the same. Okay. You try to maintain the actually process itself. So the manufacturer says, well, if I tell you 185 watts, that doesn't mean between one module to the other, and then you're going to get 100 watts, 85 watts. But I guarantee you, you're going to get a watt, at least 179.5 watts for that. Okay? Now,
that's the minimum. Now, are they saying at a specific temperature? I mean, from winter to summer, there's different temperatures.
It's all under standard condition. All the specifications that you get in the literature here, it's under standard condition.
Yeah, but then they give you that sort of real life number.
No, this is not a real life number. The real life number is when you have it out in the field and you measure it. That's your real life number. What the manufacturer tells you that the actually module performance, it would under the actually standard conditions of testing it based on the requirements of UL and so forth, it would give you between a 79.5 to a 185. Yeah, it's a certain percentage. And as I said, the tolerance of the maximum power rating is going to be what? Plus or minus 3%. Now, it's probably, if you get more radiation, there will be a lot more. Maybe you get 190 watts, maybe more than that out of that particular module. Okay? The open circuit voltage, 30.6 volts. When I measure 30.6 volts, the short circuit current, 8.13 amps. Short circuit current, again. The maximum power voltage, the V max, is going to be what? 20 watt. 24.5. Notice that the max, that the open circuit voltage, that the actually maximum power voltage is what? Much lower than that. Also what? The maximum power current. Normal operating what? Cell temperature, okay? One of the things I asked you before about the solar module, would you like to keep them what? Cool. Even though we shine radiation into it, you like to keep them cool, okay? And we're going to see how it's been affecting later. The actual what? Maximum normal operating cell temperature is going to be what? 47.5 degrees centigrade, and the maximum system voltage. What do you mean by system voltage? When you're going to connect those modules together in a serious condition, what is the maximum voltage you can get out of them? 600 volts. You can't just say, put what? A whole bunch of strings together, as many as you want, that you would exceed what? That particular voltage. Because what's going to happen there? Okay. The module is not rated for that. There are modules that you can what? That you can get a system voltage above that. All right? Which brings it back what? To the actual what? Fuse rating. There's a fuse rate. Now, here's what happens, and that's why I get to this point. If you have a short circuit current, it's less than the fuse current rating of the meter, okay? Typically 1 to 10 amps. The test leads can be connected to the output terminal, okay? The meter short circuit the device, small resistance, and we measure the current. What happens if the current in this particular module, it says the fuse rating is what? 15 amps. What happens if I have more than 15 amps in this module here? You're going to burn them out. That's why you have to fuse it, okay? Now, the next thing that they describe up here is something that they call it what? The dimensions, okay? The dimensions, and they give you the dimensions in metric, and then also they give it to you in what? In actually the English system in here. The weight, they give you static pressure, and then they give you some other information. Center of that information it's been required. One of the key things that they actually give you is what? The module efficiency. Module efficiency is 13.4% for this particular one of them. So it's on the high end compared, for this particular. You say you bought a whole bunch of them. I guess when you purchase them, did you look at the actual specifications? You just bought it. A lot of us, yeah. Okay. I'm going to go through that one more time later on because I want to show you some of the view graphs, but let's continue with that. Any questions so far? Now the efficiency of the particular modules that we're setting here, this is a what, 13.5%? Okay. Depends again on the technology, the type of material, and they go what? They vary versus, from laboratory. And how we measure the efficiency of a module? How we measure the efficiency of a module? How we measure the efficiency of anything? What you put in versus what you get out, right? What you put in, what you get out. Just think from the practical point of view. You're taking 1,000 watts, you're putting into what? A piece of material, and what you're getting out of it? 185. Plus or minus, whatever it is. So that's the actual conversion process that takes place of it defines of how well your panel is. Now, in our practical applications, when we deal with these modules, we're dealing a lot more than just the efficiency. So the easy to mount it, reliability, maintainability, the type of material we're going to use, and the whole thing. Yes, sir.
When calculating, which do you use for your voltage and current?
Excuse me?
When calculating, which one do you use for your voltage and current? The VNV and the INV?
When you're calculating what? The size for wires and stuff like that, we're using the short circuit current as well as the open circuit voltage. We're going to go through that as we go through it. How do you set up what are you calculating for the size of the wires and the actual string as we go through it. I just want to go a little bit so you can understand some of the characteristics associated to the modules before we start. Okay. Now, if you have to model to see how a particular module or cell looks like it in practical applications, is nothing more than actually you have a current source in here with actually a series parallel type of what? Resistance associated with that. So when you look at actually a physical cell, it's actually the simple that you're going to see it, but this is the actually electronic schematic that you see through it. Okay. Now both of them, the resistance as well as the series and the parallel resistance have an effect on the actually cell performance itself. Okay. Why is some of the series resistance in these devices, okay, includes a lot of time the resistance associated to the actual cell itself, the contacts associated with that, the module interconnections, and the type of the system wiring that you have, okay. You take those, you add it to the resistance of the load, and then all this stuff adds up. And you can't get away with it because it's part of the actually system. So when we're calculating a system performance, we take care of the considerations, all of those resistance associated to the wiring, to the actually devices itself. What happens with it? What kind of effect does this resistance have on the devices? If you take, for example, on a troubleshooting situations, and you measure and you see that the resistance increases, you may have electrical connections problems, and resistance obviously would do what? Reduces the voltage. Reduction of the voltage will give you what? Reduction of the power itself. Okay. If you increase the series resistance, it's going to reduce the power, it's going to change the fill factor, and obviously if you're changing that, also you're going to do what? Same irradiance, less power you're going to get out, efficiency is going to be what? It's be much less. So the resistance, the series resistance associated with the